All right, welcome everyone. This is just a video showing how to make the MS5607 non-blocking. I'm going to be jumping off of the MS5607 library by Uravu Labs, and this is by Amit Ate, and they've written a really great library here that interfaces with the sensor. But what we're going to do is we're going to modify it, I've already kind of modified it, but I'll sort of go through how I've modified it to make it non-blocking. Because what happens with this sensor is that it needs to have a delay of 3 milliseconds at certain points in time when it reads data. And that delay is not good when you're trying to write time-critical code. And so it's better to basically have it non-blocking, and we're just going to go through how to do it. So yeah, this is the library that we're sort of jumping off from, and I'll show you sort of the code here. So here I have like 4 files. So here are the files from the library, and here are the files from my own sort of my own functions, right? So this altimeter.cpp are my own functions that I use, like initializing the altimeter, handling the altimeter stuff, and getting the altitude bias. But these things don't really need to be here. You don't really need to get moving average or even get the bias. That'll be up to you to worry about. But yeah, so the reason I'm doing this video is because right now I want to clean up my implementation of this library a bit and make it usable as just like a standalone library. So yeah, let's get into it. So let's just look at the original MS5607 library that I've modified a bit. So I guess in this case, yeah, so I've modified it, and let's just go down to, let's see, where do they start reading? Okay, here we go. So this is the function that I made here, and this is basically a handle altimeter function. And what that does is, or the way it works is basically it's a state machine. It's a finite state machine, and rather than getting the sensor to delay every 3 milliseconds and wait for that information to come back from the sensor, the state machine just basically says, okay, we're in state 0, so we're starting the conversion, and then we're going to do whatever else we need to do until we call handle altimeter again, and then we're going to check if the 3 milliseconds has passed, and if so, we're now in state 1, and we're going to start the actual measurement, and then we go do whatever we need to do until we call handle altimeter again, and then we go into state 2 and we look at the time. So it's kind of like, rather than being like, rather than going to the sensor and sending a command to the sensor and just waiting there, stopping for 3 milliseconds and waiting there, what we're doing is we're sending a command to the sensor, and right away we're going to do something else. And then after that something else, we call handle altimeter to come back to the sensor, and we're going to see, oh, did 3 milliseconds pass between the time that we started and we came back? If so, okay, now ask the sensor for the new data or for the new thing. And the reason that it's a state machine with 6 states, or I guess 7 states, is because there's a bunch of steps that you have to do to actually get the proper data from the sensor, and you have to wait a certain amount of time between the steps. And actually, it's more than 3 milliseconds, as I can see here. It's actually, you have to wait 10 milliseconds in certain cases. So in total, this thing will wait like 10 plus 3, about 26 milliseconds or so, if not a little bit more. Yeah, but it's not going to wait. Obviously, it's just going to check and stuff. So yeah, it basically starts the conversion, and then basically once we start the measurement. Then after a certain amount of time, we start measuring, then we get the digital value, then we have to start the conversion for a different part and get a different digital value for the temperature, and then finally we can get the finally we can actually like get the altitude, right? So we can actually calculate the altitude. And here, get altitude is just a function down here. And that just basically just gets the temperature and pressure. And temperature and pressure, get the temperature and pressure, are just basically the values that we got are the big DT values, right? So big DT, and there's also, I think, a big DP here. And those values are the ones that the start measurement gets us, right? So like the get digital value and the get digital value gets us here. And so the get temperature and pressure like actually does the calculations for the actual temperature and pressure based on the byte value, like the bits and the bits that we get from the sensor. And so this isn't blocking, it's just a calculation. And then we just convert that to like a height based on pressure. And then we just return h. So return h is just the height. So where we return it into this internal altitude. We just put it to this internal altitude variable here. And then we just say data available equals true, and then we're going to return 1 if we're ready, basically, right? So and every other time when we don't have new data, we just return 0. And this is important because so now this is like the internals of the library. So if I go into my own library here to altimeter CPP, and I go into handle altimeter, actually I think that even this can just be taken out. And even this. So it's up to you to sort of get the altitude bias, but it's sort of like you basically just call handle altimeter, right? And the altimeter will either give you a 1 or a 0. And if it gives you a 0, you can get the altitude. And to get the altitude, it's just, let's see. Oh yeah, it's just the variable raw altitude. So to the altimeter library, you already give it a raw altitude. So I'm going to actually, I'm going to, let's see. Also, like, for the first measurement, I make sure to like have a while loop that just does handle altimeter until we get a new data, because I think the first piece of data just is wrong or something like that. But let's just go like this. So we really don't need to modify, like, the thing is, like, the library, this MS5607 library, it's all, you don't even need my library anymore. Or like my specific one. You can use this MS5607 library as it is. Let's say this is the non-blocking one, or let's say, yeah, this is the non-blocking one. So we can even say non-blocking CVP, and then here non-blocking .h, and just make sure to rename. I'm just going to make sure to rename this. Okay. And let's just go back to here. And what is a license? General public license. What is the general public license? Let's just look at it really quick. Because I want to make sure. There's got to be a better. There's like a website that shows you what you need to know to choose a license. This one, there we go. Okay. I mean, this is how to choose it, but it doesn't tell you what it does. So, GNU, this is v3, which I feel like it's going to be close enough. Permissions, commercial use, condition, disclose source, license, copyright notice, same license, state changes. Yeah, changes have been made, modification will be released on the same license, license and copyright notice must be included in the license material, disclose source code must be made available. Okay. We can modify, it can be modified, it can be distributed. Yeah, okay, cool. So we're good. Let's just look again real quick. Yeah, okay. So let's go back here. So we can say, modified by Merchriac to be non-blocking, and then this okay. Sure. There we go. So these functions here, math.h and include wire.h, this is just because it needs to use the wire peripheral. And I think my wire, yeah, so my wire peripheral is wire 1. So this is kind of going to be up to you to change this. So I think I'm just going to change this back to wire. So everywhere where I see wire 1, I'm just going to switch it back to just say wire, because, and I'm just going to make sure it switches the right stuff. Because usually people use wire and the default is wire. But I'm using wire 1 because that's what my sensor is connected to. So you're going to have to make sure to put it to the right wire. We could modify a bit again. Yeah, we could modify it again, and we can set the wire, but then I'd have to do all this. Yeah, I'm not really sure how to modify it so that it includes the right wire peripheral. So you just have to use the correct one for yourself and go into this and modify it. Yeah, so an example, let's say an example of how to do this. Also, there's like set oversampling ratios and things like that. So an example for how to use this, well, let's say we make a new file. We say, flight computer dot, or let's say main.cpp, right? Boom, and then we say, include arduino.h, and then we say void setup, and then there's going to be a void init, or not init, void loop, whoops, okay, cool. And, let's say, in this case, we also want to include MS5607 non-blocking. There we go. So then all we have to do is, let's just look at this code again. We have to basically say MS5607 and give it an altitude variable, which is a float. Yeah, so we can say float altitude, and then MS5607, and then we're going to say altimeter. We have to give it a float, so we're just going to give it an altitude. I think, I think it uses the address to it, right? So we're actually going to have to just give it the address, I think. So it's at altitude, right? And so that you don't really have to do anything in setup unless you want to like init the altimeter yourself. So if you need to initialize it, actually, sorry, yeah, you need to call begin. My bad. So wired up begin and then recalibration basically. So it's basically this. So let's do that. So here we would do altimeter.begin, and that's it. And you could give it a delay, whatever, but here we can do a void loop. So this is where it's kind of where the non-blocking situation happens. So, so what we could do is say, okay, if altimeter dot handle altimeter equals true, right? Because handle altimeter equals 1, because handle altimeter will give us a 1 if there's new data and a 0 if there's no data. So basically it's going to be checking each time in the loop. It's going to run this function and it's going to say, does this equal 1? And if so, we can say, serial.print what is it called? I guess raw altitude, right? Just like that, easy. And there you go. So that is non-blocking right there. Another, so that would basically be the end of the video, but let's say another useful feature of this is, another way to do this is to use the Chrono library. This is one of my favorite libraries for flight computers. And I don't have it included here, but Chrono, you can find it on GitHub. And Chrono, basically it works like this, where you say Chrono, let's say altimeter timer. And actually, I feel like in this case, you don't really need it. Yeah. Well, let's say you can do altimeter timer, but I'll show you like a use case of it. So you say chrono altimeter timer, and let's say you want to, we just established a timer here. So let's take this out here. Let's say you want to perform a task every 20 milliseconds, right? So rather than having to check, hey, is millis more than current time or things like that by 20 milliseconds or whatever, all you have to do with altimeter timer or with chrono is you say if altimeter timer dot has passed 20 milliseconds, then, you know, do a thing function, and then you just say altimeter timer dot restart. I think it's actually like that, something like that, yeah. And what this does is basically every time 20 milliseconds has passed, this thing will happen. And then you just restart the timer and it does it again. And you don't have to, so now you don't have to like have keep track of variables for, you know, current time and having to worry with millis and all that stuff. And it just makes it much cleaner. You can go one step cleaner to say, hey, how about void handle doing a thing, right? So handle doing thing, right? So this is sort of my way of like, I write a lot of these functions where it's like handle doing a thing. So it's not the function doesn't necessarily do the thing all the time. Like it's not going to do it every time you do it. What it is, it handles it. So you can take this code and put this into here. And so now, in this case, this code here, I just have to write handle doing thing, and it keeps my loop cleaner, and and then like it's just cleaner in the loop here, and then you can separate into separate functions. So you can say, hey, when I handle, you know, reading the altimeter, I want it to, or let's say when I handle, you know, updating my PNID loop, I want to have it done every, you know, 5 milliseconds, and there it is, right? So you keep the timer in here and the doing the thing here, and then here this loop down here is just handles, it just keeps running, and it, you know, it's just cleaner down here to see. Yeah, so, but that, anyways, that's a bit too far in that, but yeah, the function, all you have to do is just do altimeter dot, what is it? Handle altimeter, I think. Yeah. So it would just be handle altimeter, and every time you get back a 1, you know that your altitude variable has been updated, and you're ready to go, basically. There's some stuff here that you don't really need, I think. So there's this data available. Yeah, there's a data available here that we do. There's an is data available function that I did, but I don't think we need it because we're basically, the data will be available if we return 1 from here. So we don't need it. So I think, yeah, I think that would be fine. That's it. But yeah, the way it works, it's just a state machine. It goes through all these states to convert, to do the final conversion, and each of these states takes a certain amount of time. And so we just, you know, start the next state every time we handle altimeter. So what will happen is actually when we call handle altimeter, we'll have to call it 1, 2, 3, 4, 5, 6. At least we'll have to call it at least 6 times, or I guess even 7 times. Yeah, at least 7 times to get the altitude. But you know, if it's running, the fastest it can go is about 30 milliseconds, 26 milliseconds or so. Like the fastest it'll get through all of this, because we are having to come back, well, give it time for the conversion steps. And I think these numbers are the ones that were in the library originally. Also, there's like, yeah, like for resetting device, you're not doing this in the loop, so it's fine if there's a delay here. But yeah, there's even the data sheet, I think, tells you should like delay for like 3 milliseconds, which is kind of dumb. But yeah, so that's the non-blocking library. I'll put this up. Let's put this up on GitHub. So this is I mean, can I just fork this? Well, I'll put this up on GitHub, actually. Yeah, let's just do that. So we're in this folder, Review and File Explorer. Cool. And I've got a lot of these things. So here we go. So I'm just going to take away this main.cpp. And then we can go open with, let's see, I have a we GitHub desktop, and we're going to make a new, we're going to go file, new repository. And this is going to be called MS5607 non-blocking. Or just, I don't know, can you do spaces? Yeah, no spaces. Sure. A non-blocking library for the MS5607 uses a finite state machine to, yeah, oh, whatever. Yeah, let's just say non-blocking. Local path. The path is actually in my desktop. Ooh, this is a lot of stuff. There it is, this folder. Initialize with a README, license, the same one that we had before, right? So what was that license that the guy had? v2.0. So GNU v2. Is it? GNU General Public License, yep. No git ignores, and we can create the repository. There we go, so it's created. I'm going to publish it. I'm not going to keep it private. And publish. Okay. And let's make a README file. So let's just see, did it create the README for me or not? Did it make a README? Do I need to add a folder? Not blocking. Oh, it's inside here. There we go. Oh, whoa, what happened here? Let me go back to the files. Ah, okay, so it put them in the wrong place. There we go. So now we have these files, and we have a README, and GitHub has noticed the CPP file, the .h file. Sounds good. And let's go back to this README. And let's just write, yeah, let's just write how to do it, right? So we'll go here. We're going to say example, okay, let's, yeah, example usage, MS5607, and say my altimeter, but we'll make sure we say float, altitude, and we're going to, oh, why is this, okay, float altitude, and then address, altitude, and then we say void setup, and we go my altimeter dot begin, and then void loop. We can say, oh yeah, what was it? Oh yeah, if my altimeter dot handle altimeter equals 1, serial dot print ln altitude. There we go. Yeah, so that, yeah, and then we're just going to say, you know, make sure to give, to initialize MS5607 class with the address of your altitude variable. Or let's say handle altimeter equals 1 when conversion of data is ready and new altitude is ready. It equals 0 when there is no new altitude yet. Okay, there we go. That should be simple enough, I think. Let's just also say, based on the library by Uravu Labs, And let's put a little link to it here. There we go. Okay, cool. So that's our README. I don't really know Markdown very well, so I'm just gonna leave it. Actually, I think it's like things like this. We go do like that, right? Ah, there we go. Right. Cool. That should be fine. Let's now upload it. Commit initial commit. We've already kind of pushed it initially. And let's go to my repositories and look at it. There we go, non-blocking, there it is. Cool, example usage, okay. It's not the best, yeah, it's not the best things here, but let's say, I think that works. Yeah, so it'll, there we go. So we're just modifying the README file. And it should be modified. There we go. Boom. Example usage. Blah 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 blah. Okay, that should be close enough for people. Let's say Markdown add code. Add code. Markdown cheat sheet. Headers. Emphasis. Lists. Links. Images. Code and syntax highlighting. Okay. So it's just dot dot. Okay, it's just those. So let's do that. If we can do this, we can do that. CPP, is it gonna know? Yeah, I think it knows. Sweet. Okay, I like that. Let's commit that to main. And we're back. Okay, we're here. Hey, there we go. Look at that. Cool. Awesome. So this is the non-blocking library. Yeah, thanks for watching. Like and subscribe to my channel if you enjoyed this sort of tidbit of random stuff. And yeah, I could have done this without making a video, but I thought I'd like to make a video and try out my new lav mic. Hopefully the audio quality is good. Yeah, if you have any questions, please open up an issue on GitHub. Oh, sorry, you don't even see the GitHub page. Hold on. Let me show you how it looks like now, because it looks real nice. This is it. Yeah, see, look at that. We got code here and highlighting, and yeah. So, anyways, like and subscribe. And if you have any questions or issues with the library, please click this issue button up here on the top left and open up an issue. Because that's probably the best way to like let me know about these things. Yeah, and it helps documentation. Anyways, thanks for watching, and I'll see you next time.